Just, we contacted each, put in contact.
Condo.
I sent the deposit on August the 6th.
So at the beginning of it, you told her that you were canceling, and you sent her a deposit, $2,000.
Correct.
At some point,
Well, a portion of my deposit back, correct.
as opposed to 3 months.
Right.
You know, if you have a place, people want to rent it for the winter season, they can rent it for months.
Right.
You said, well, my parents might want to go for 2 weeks.
Right.
So we can take that off the deposit.
Correct.
Whatever it is. But you were getting a preferred rate because you were renting it for 3 months,
Correct.
right?
Yes.
And how much of a preferred rate were you getting?
I don't know exactly because her
Well,
rates change on Airbnb. She offers special deals. It's hard to say.
How much do you think you were getting in a special deal because you were renting it for 3 months, so she knew she had a good tenant?
Right.
How much do you think?
It's hard
You
for
don't
me
know.
to say. I really don't know how much.
You have any texts from her discussing the price of the condo?
I do.
I'd like to see it.
Sure.
So you reached a contract, and you did have a contract. Do you understand that you had a contract?
We had a, yes. Okay.
You had a contract.
Okay.
There was an offer,
Right.
an acceptance, and consideration because she said, I'll block my Airbnb calendar now
Okay.
that we have an agreement,
Okay.
which she did. Okay, and then we go on to August 6th when she says to you, hi guys, did you make the deposit yet? Not to rush you, but just got an offer from Canadians for the same dates on Airbnb. And you responded, will do today. We're taking it for sure.
Right.
Please do not give it to them.
Right.
Well, why do you think you're entitled to your deposit back?
Because when I canceled, we changed the agreement.
Show me what day in March. I'll try to rent my place out for the time you had reserved, which is January.
Not for that whole period of time.
For a good portion of it. Almost all of it.
And you know that.
I have evidence.
Great. Sir, is going to cost you a lot more than my deposit. You'll be sued for both the cost of my parents' plane tickets and all associates. Trust me, you don't return here.
My
Just show me-
boss,
just
the
show- just-
realtor.
with the nature of his complaints that you refused to return his deposit?
But does he have a right to do all that?
Yes, of course.
For your worst sore throat pain, try Vicks VapoCool Drops. It's not candy, it's powerful relief. Vaporize sore throat pain.
There will be some tennis, right?
Not really. What about football? Not in the traditional sense.
Okay, then what skills do we need?
Courage? Come and get it! Elite athletes, epic challenges. Game on. New series tonight at 8, 7 Central on CBS.
Here's something the insurance company doesn't want you to know. On average, people with a lawyer get over 3 times more. Let my firm fight for you.
Enjoy $1,000 savings on Sealy Choice of Comfort mattresses during Mancini's Sleep World's Memorial Day sale. Purchase online, by phone with a sleep consultant, or now by private in-store appointments at select stores. Visit us at sleepworld.com.
AAA Auto Insurance isn't just about metal and tires. It's about the people inside and making sure everything you need is there with you. Like a AAA membership with roadside assistance, local agents ready to bundle your insurance policies, and auto repair experts close by across the nation. Outsmart the road with award-winning insurance and more. AAA.
With our homes more important than ever, Living Spaces is here to help with great values to help stretch your dollar even further. And during our Memorial Day event, you'll find great deals for your living room, bedroom, home office, outdoor spaces, and more. Plus, pay no interest for 36 months with your good credit and get free 2-day shipping with minimal
my feelings in Oklahoma. Here they do a lot of feelings. In California. Then you wrote again in January, and it says, Paul, have you returned my deposit? You have rented the apartment for almost the entire time I sent the deposit for. It is not fair for you to keep my deposit. That's true. If she rented, she has to deduct from your deposit what she would.
You want to know that it's going to be affordable. Before we talk about the warranty, think about other things you've bought. Did it sometimes feel like you had to buy the expensive extension?
$1,000.
Thank you.
Thank you.
Parties are excused. You may step out.
Judge Judy, I have a countersuit on.
Oh, bring him back for a second. Because he defamed you. Listen to me. He defamed you on Airbnb.
Not only on Airbnb, to the Board of Realtors for
Just
Mexico, my
just show
boss.
Python web framework that we were able to use to continue to design things like a model already in place for how to authenticate users, how to log them in, how to log them out, how to remember that a user is logged in. It also gave us access to a really nice and easy to use administrative interface, which made it such that if we wanted to very easily add new things to our models, it was very easy to do that. And it also gave us the ability to enforce relationships between different models in ways that was easier than we would have had to have done previously, whereby if we wanted a relationship, for example, between flights and individual passengers, rather than have to create for ourselves another table that would relate an individual flight ID to an individual passenger ID, we were able to leverage Django in order to simply say that we want there to be some sort of many-to-many relationship between flights and passengers, and taking advantage of that relationship, intermediary table, and Django goes ahead and creates that. Well, we don't need to worry about how exactly Django's doing it. We just need to worry about what relationships we want. And so before we dive into the main focus of today, which is going to be about testing and also continuous integration and continuous delivery, we're going to talk a little bit more about Django and the features that it gives us, to touch on a couple things that we didn't quite get to last time in order to answer a couple of questions that people have had. And so the first thing we'll take a look at is inside of the same airline example that we've been using. We'll take a look at how we might customize the administrative interface. And so a couple questions were raised during the last lecture about whether or not we could change anything about the administrative interface, that thing that's automatically created as one of the built-in Django applications. And in fact, there are things that we can do in order to customize it to our liking. There are, in fact, many different options that we have available to us. But I'm just going to show you a couple just to give you a sense for what's possible. So if I go into admin.py, which is the place where in last lecture we really just had these 3 lines at the bottom where we registered our airport model as something that we should be able to edit in the admin interface, in addition to the flight and passenger model as other things that we wanted to be able to edit and modify in the admin interface. What we can do is extend the existing model admin class in order to add additional features that we might want. And the full list of all of these features is available in Django's documentation, but I'm just going to show you a couple that might be interesting or of use. So one, for example, is that you can determine how users are able to interact with particular data points. So for instance, I'm extending the model admin class to create a new class called passenger admin. And this is going to be a special set of configuration settings that I'm only going to use when I'm editing passengers. And I use that down here. When I register the passenger class for the admin site, I'm saying use this special passenger admin class, which is going to contain additional settings or additional information about how I want the user of the admin interface to be able to interact with passengers. And in this case, I'm using this special variable called filter horizontal, which is going to give me a really nice way of taking a passenger and manipulating what flights they're a part of. So I'll show you what that looks like. Filter horizontal is one of those built-in settings that I can manipulate using Django. And if I run the server now and go to this URL, and I'll go to /admin to get to the admin interface, what I can do is now when I go into passengers and I click on an individual passenger like Alice, what I get is this is what the filter horizontal administrative window looks like. I now get a really easy way of controlling what flights that they're on. Before, if you recall from last week, I was clicking and I was control or command clicking on different flights to either select or deselect them. Now I can determine what flights Alice is on just by clicking on a flight, moving them back and forth. Now Alice is not on any of the flights. If I click on another flight and move it over, now Alice is on both of these flights. And so these are just small changes I can make to change the appearance of individual flights. And one other thing you might have noticed from last time, and before I do that, let me go back to the way it was before. If I were to go into admin and go and edit an individual flight, for instance, I want to edit flight number 1, you'll notice that normally what I get are just the options to edit the properties of that flight. I can edit that flight's origin, I can edit the flight's destination, I can edit the flight's duration, but I can't, built in here, edit the flight's individual passengers. And why not? In the passenger side, I was able to edit the flights, but I can't seem to do the reverse. Well, the reason, if we look into models.py here, is that if we look at what properties the flight has, we only define origin and destination and duration. Whereas for passengers, we define their first name and their last name and this additional property called flights that was associated with passengers. So therefore, when we go into the passenger admin interface, I can edit what flights that passenger is on. But when I go into the admin interface for editing flights, I can't control what passengers they're on. And so this is something we can also solve just by doing some customization of the administrative interface. So what I'm going to do is first define a new class which extends stacked inline, where stacked inline is just one of Django's built-in classes that lets us, in a stacked format, add new relationships between objects. And so I'm going to call this one passenger inline, and you'll see why in a moment, where this is going to be the class that represents the place on the admin interface where I would like to be able to add and modify passengers. I need to specify what model I want to use, what data I want to be associated with this class that I've just created. And in this case, I'm saying passenger.flights.through. This additional .through property refers to that intermediary table. So recall that we have a passengers table and a flights table, but there is some sort of relationship table between them, some table that connects individual passengers to individual flights. And this .through is how I sort of access that intermediary. And extra equals 1 just means that I want to be able to add one additional passenger at a time. And you'll see what that looks like in a moment. And then in the special flight admin class that I'm extending from the existing admin class, I'm saying I want to add this additional inline section of the admin page called passenger inline, which is the one that I created up there. And so if I now register the flight model to my admin site, specifying that I want to add these additional settings in the flight admin settings, now when I go to edit an individual flight, in addition to getting to edit the origin, destination, and duration, I also see this view, which is the stacked inline view, where it's just a stacked list of all of the passengers on this flight, whereby if I want to add an additional passenger to the flight, I simply need to go down here and select which passenger that I want to add. Of course, in this case, both passengers are already on the flight, so it wouldn't make much sense for me to add one of those passengers again. But that would be the sort of thing that right now our application can't handle, but you might want to add additional constraints that help enforce. And so the goal of this is just to show just a very brief teaser as to how you might be able to manipulate or customize the administrative interface to look and feel exactly the way that you want it to do. And if you take a look at the Django documentation for the admin interface, there are a whole lot more settings than just the couple that I've shown you here, but that you can get a taste for, that you can experiment with. And I would encourage you to experiment with it as you work on Project 3, just to get a sense for the different ways that people can begin to interact with this administrative interface that Django has really built out for you. The other thing that I wanted to touch on last week that we didn't quite get to was how to deal with static files. So a couple people have asked about how you use static files in Django, like CSS files or JavaScript files that are external. So the way that you would do that in Django is inside of our HTML file, so one of our Django templates, what we would first need to do at the top is use this additional Django command called load static, which loads static files into this page. And then if we wanted to reference a CSS style sheet, for example, this is the specific Django syntax for doing that. So it looks a little bit different than the way it looked in Flask, for instance. But inside of the curly braces and percent symbols, we'd have the static keyword just to say we want a static file to be used here. And then which static file? Well, it'll be the flights directory and then styles.css. And if you look at the structure of our application here, inside of the flights app, I have inside of it not just a templates directory that has flights and then base.html along with all these other HTML files, but I also have a static directory inside of which is a flights directory, inside of which is this styles.css file, which is the static file that I want to load in all of my HTML files. The question also came up last week as to why it is that we need this additional flights directory. In the same way that we had an additional flights directory inside of templates, we also have this additional flights directory inside of the static directory, which feels a little bit redundant because we already have a flights directory, which is the name of the entire app. And the reason, again, is the same exact thing as before. It has to do with the fact that if I had multiple different apps, each of which had a styles.css file, for instance, appending flight / in front of it helps to namespace that file to make sure that I know how to reference it in order to access it. So just wanted to show you those things just to give you a sense for a couple final things in Django that are possible that you may be interested in doing as you go about working on your project, though it may not actually in the end come up. But the main focus of what I wanted to talk about today is ultimately going to be about testing. And so as we begin to develop more and more sophisticated, more complex web applications, it's going to be increasingly important to test that code in order to verify that it's accurate. And so reasons why it might be good to test that code are to make sure that if I'm making changes to one part of the code base, making changes to one function that might be used in a dozen other places across the application, I want to make sure that the changes I'm making to this one function aren't going to cause some other part of the web application to break, for instance. And it might also be important because I want to anticipate the fact that functions may behave differently based on different types of inputs. And so I want to account for the fact that no matter what sort of input I provide, I want to know that my application is going to be able to handle them well. And so what we're going to spend a lot of time today focusing on is how to build out a system for testing. First of all, how you would even test things on your own, but then looking at what tools and technologies exist in order to help facilitate the testing process, which ultimately becomes very, very important as we begin to develop more complex web applications. So to take a just very simple example, I wrote inside of, let's go to the source and go to prime.py, which is a function that I wrote inside of a file called prime.py. I wrote a function called isPrime. And what this function does is it determines whether or not a number is prime. And this has nothing to do with web applications just yet, but I'm going to show you this example as a function that I might want to test to see whether or not it's accurate. And then we'll go from there in order to later explore how do we apply these same ideas of testing a function in command line Python to going on to how do you test functions in a Django web application, for instance. So this function isPrime is going to take a number n, a non-negative integer, and tell me whether or not it is in fact prime, returning true if it's prime, returning false otherwise. And the basic logical flow for this function is that if the number is less than 2, well, it's not prime because 2 is the smallest prime number. So we'll go ahead and return false. And then I'll run a loop going from 2 up until the square root of the number. Math.squareRoot is a function that gets me the square root. And if it's the case that n mod I, where mod is an operator that gives me the remainder when I divide n by I, if I divide the number I'm looking at by this I, this variable in the loop, and that number comes out to be 0, in other words, n is evenly divisible by I, well, that means that the n is definitely not prime because I is one of its factors. And so I'm saying return false, the number is not prime. And then finally, if I made it through checking all of these factors up to the square root and none of them divided n evenly, then I can say that this number is in fact prime. And so at the end, I'm going to return true. And so this is the basic logic for the isPrime function that I wanted to create. And now my goal is going to be, how do I test this function? How do I evaluate whether or not it's going to work or not? So one thing I can do to test it is just to test it on my own. So I can open up the Python interpreter and say, from prime, import my isPrime function. And now I have my isPrime function, and I can test it. I can say, OK, isPrime of 23. Well, 23 is a prime number, so this should return true. It should be prime. And it does, in fact. And likewise, I can say, isPrime 28. Well, 28 is not a prime number, so this should be false. And so I press return, and indeed, it does turn out to be false. And then I could try isPrime 25, for instance, to see, well, 25 is not prime either, because 5 is one of its factors. And OK, something seems to be wrong with my isPrime function. My isPrime function thinks that 25 is, in fact, prime, when in reality it's not prime. So I found some sort of bug or error inside of my isPrime function. But all of this is ultimately going to be pretty tedious, because as I think about using this function in the broader context of a larger web application, where I'm constantly making changes to different parts of the code base, where I might be changing different aspects of the function, I don't want to have to, every single time I make a change to the program and I want to make sure that the isPrime function is working, to go in here and type isPrime 23 and 28 and 25 and try a whole bunch of examples to make sure that it's going to work. So what might I do instead? What are some other things that I could do just to simplify this process or make it so I don't need to manually go into the Python interpreter every time and try out the isPrime function on a bunch of different inputs? Great, exactly. I can write some sort of program that's just going to run a whole bunch of these for me in order to make sure that I have the right idea. And so let's try doing something like that. If we open up test0.py, what I have in test0.py is a very simple Python application, or really just a Python module that contains a single function called testPrime that is going to test whether or not I get the expected value that I want. So if I feed into this testPrime function a number n, and a Boolean value of what I expect the result to be, this expected value, then I can check if, so run the isPrime function on n, because I imported it up here at the top, and if I check the isPrime function and it's not equal to the expected value, in other words, when I performed the computation, it wasn't what I expected it to be, based on what I thought the test should result, then there was some sort of error. There's some sort of error in my isPrime function, and so I'll print something like, there is an error on isPrime n, where n is whatever the number. We expected it to be whatever we expected it to be. And so this function is going to simplify the process of allowing me to test whether or not a number is prime. And so in order to use this, now I just need to call the testPrime function. So I could write a Python file, for instance, that just used the testPrime function over and over again in order to test whether a number is prime. Another thing you'll sometimes see is people writing just a bash script, just a script that's going to run inside of the terminal shell without anything more. And so the way bash scripts work is that they'll generally just be a bunch of lines of commands that I might run on the command line. And in this case, Python-C is just a way of saying, run this particular Python command. And so on line 1, I'm saying, run this Python command. First, import the testPrime function, and then test to make sure that 1 is not prime. And likewise, I'm doing the same thing on this line, saying test to make sure that 2 is prime, and make sure that 8 is not prime, make sure 11 is prime, so on and so forth, testing all of these possible input values. And now, if I wanted to run this, I could run that script. And what I get is for the 2 for which the number did not match the expected result, where I ran isPrime 8, I expected 8 to not be prime, but there seems to be some sort of error here. I get that there's some error that's listed here. And so that's helpful. Now, anytime I make some sort of change to my web application, or my application in general, I can run a sample test file that's going to run a whole bunch of these tests. and then give back to me some information about any line of output that I get here is a sign that something wasn't quite right, that something went wrong over the course of me trying to test this function or this application. So if we go back to prime.py, I can begin to start debugging this, try and figure out what exactly went wrong. Does anyone have a sense for what might be wrong, out of curiosity? Why it seems to be thinking that more numbers are in fact prime when they're not. If you played around with it for long enough, you might find that it has to do something with this loop, that for some reason I'm not testing enough possible values in the loop. And in particular, it has to do with the fact that when Python does loops in a range, it includes the first thing in the range, but it excludes the last thing in the range. So for instance, if I do for I in range 0 to 5, print I, what I get is I start with 0, and it goes all the way up to 4, but it doesn't actually include 5. So it includes the first thing in the range, but it doesn't include the last thing in the range. This is a common source of what we call off by 1 errors in Python and other languages, where we had the right idea, but we were just off by 1 number in something that we were trying to calculate. And so the problem in this isPrime function just happens to be another one of those off by 1 errors that really, in order to include that final number, that square root that I want to test, I additionally need to test that last number, the actual square root itself, or the number closest to it if it doesn't have an integer square root. And so now that I fixed the function and I want to test it, rather than go back into Python and then saying from prime import is prime, and then testing all of these individual values again, all I have to do is run that test file again. And this time, the test file produced no output. Remember, output was only going to be produced if there was some sort of error, if there was a line that was incorrect. And now when I run the test file, I get no errors, which tells me that at least for the inputs that I've provided, the tests seem to be working. Now, this doesn't mean that my function is necessarily totally correct, because it just means that whatever tests I decided to give to this program, it passed those individual tests. But that's where it starts to become important to write good comprehensive tests, to make sure that if you're going to test a function or a particular part of your application, that you're really testing it under all possible conditions, that we have tests for even numbers and odd numbers and different types of numbers to really try and get a sense for, is this function really correct, by testing it on as many different things as we can. And that's going to be important as we start to build larger web applications that are getting more complicated. We want to make sure that our tests are testing as many different possible situations that might come up as possible. Questions on anything so far? OK. So we'll take a look at a couple other features of Python that might be useful as we go about testing. And one thing is Python's built-in assert command. And so the Python assert command really does one thing and one thing only. It takes the expression that comes after the word assert, and it asserts or just states that this expression is going to be true. And if it's not true, then Python will throw an error, the same way Python throws an error if you try to divide by 0, for instance, or access something in a dictionary that doesn't exist. It'll throw a particular exception known or it'll throw an assertion error. And so if I assert, like the statement true, for instance, nothing happens. It just states that it was true, and it's not actually changing or modifying anything. But if I assert something that's false, then I get this assertion error exception. The whole program quits, and I get this error that says the expression that came after the assert was not true, so there was some sort of problem. And so this can be useful if I'm trying to see whether or not a program is working correctly or not, because if I want to state definitively that something is supposed to be true, I can assert that it is true. And if it's not true, then my program is going to give me some sort of error. And so if I look at assert0.py, for instance, here's a very simple file that is just going to define a function called square that takes a number x and returns x times x, returns the square of x. And down here on line 4, I'm just going to assert that the square of 10 is equal to 100, because that should be true. The square of 10 should be 100, and I want to assert that that is, in fact, the case. So now if I try to run assert0.py, nothing happens, right? Assert doesn't print anything to the screen or have any other side effects. It just asserts that the thing that comes after it is, in fact, true. If it's not true, and in assert1.py, for instance, if I try to assert a fact that is not true, I try to assert that the square of 10 is 101, for instance, instead of 100. Now, when I try to run assert1.py, now I get this assertion error. because the thing that I was asserting was in fact false, and so the Python program is going to give me some error. It's going to quit and say that something went wrong. And in particular, all programs, when I run them, give me some sort of exit code that indicate whether or not the program ended in a particular state or not. And generally speaking, an exit code of 0 means the program ended and everything went well, and an exit code of something other than 0, like 1 or something else, means that something went wrong as I was running this particular program. And in Bash, in the terminal environment that I'm using, if I want to look at the exit code, I can type echo $? And here, I see that the exit code of this program was 1. Something went wrong, and therefore, this program exited with a status code other than 0. Whereas meanwhile, if I had just run assert 0.py, and I looked at what the exit code of that exit code was 0, because everything went fine, there was no problem. And so we'll return to this idea of exit codes and how we can use the fact that exit code 0 means everything's OK, and exit code 1 or something else means something went wrong a little bit later. But this just gives you the sense that we can use these assertions to either have some sort of error if something goes wrong, or do nothing if everything was OK. But of course, it's going to, again, be tedious if we continually have to write these assert statements after assert statements all the time in order to verify that things are correct. It would be nice if there were some easier ways to do this. And Python does, in fact, allow us some tools that make it easier to do testing. And in particular, they have a framework called Unit Test, which is a Python library that's designed to help make it easier to test your programs. And so we'll take a look at Unit Test, and then we'll look at how we can apply Unit Test to actual web applications. And so what we're building up to now is in tests1.py. And so this will look a little more sophisticated. And what we've done here is first import unit test. And now I'm defining an entire class. This class is going to extend unittest.testCase. So it's a class that's going to contain a whole bunch of individual tests that I want to run on my code. And each test is just going to be a function or a method inside of this class. So I define a test called test1, and this docstring here, this comment, is just a label for the test, such that if the test fails, then I'll know something about it. I'll be presented with this label for it. And so the name for this test, my description of it, is that it's going to check that 1 is not prime. And unit test has a whole bunch of these built-in functions for asserting things. Rather than just a plain old assert that says assert some expression, there's a special assert false, for instance. And I want to assert false is prime 1. In other words, assert the fact that if I evaluate is prime of 1, that should be false. And likewise, in test 2, and I want to check where I want to check that 2 is prime, I can likewise call is prime applied to 2 and assert that the result of that expression should be true. And so I can define a whole bunch of these functions, each of which is just going to be an individual test that I want to run. So here's checking that 8 is not prime, checking that 11 is prime, checking that 25 is not prime, checking that 28 is not prime, for instance. And then at the end, down at the bottom, I'm just going to run unittest.main, which is going to run all of my unit tests. In other words, run all of these individual functions. And so if I now run test1.py, then what I get is that it says it ran 6 tests in 0.001 seconds, and OK, everything was fine. So nothing went wrong in this case. I didn't get any errors. If I change my prime function and put that error back in, such that now the isPrime function is buggy, and now I try to run test1.py, now I get a whole bunch of these interesting errors. So up here at the top, it's telling me what happened. This dot just means this first test passed, it passed, it passed. This one failed, then it passed, and then this one failed. And now it's going to tell me which test specifically failed. So I failed the test25 check, which is the check that's going to check that 25 is not prime. Again, this was that description line that I included in that triple quoted docstring. And then it's going to tell me, all right, what was the line that caused the assertion error? Well, the error was here where I was asserting the fact that 25 should not be prime, that isPrime 25 should evaluate to false, and it was an error because true is not false. And likewise, I got the same error on this test8 function, where I wanted to make sure that 8 is not prime. And likewise, I got another assertion error there as well. And so that seems like a little bit of overkill for a function this simple that's just testing whether a number is prime. And it seems like we probably could have done this without using unit test, and in fact we did. But as we begin to want to test more sophisticated, more complex programs, we'll see how the value of unit test really comes in and how we can begin to build on this in order to make our tests more comprehensive, make the process of running tests even easier. But questions about anything we've seen so far with just unit test before we move on? Yeah. Good question. The echo command is just a Unix command that basically just prints something out. And in this case, I wanted to print out to the screen the return value or the exit status of the previous command that I ran. Yeah, good question. OK, so that was unit test in the context of just a basic Python file, a Python module that contained a function. Now let's try and apply this to unit test in the context, or unit testing in the context of an actual web application. And so let's go into airline 1 for now. And we'll take a look at inside of our flights application. We've been looking at all these various files that we've had before. So we had this admin.py file, which we saw before helped us to create the admin interface however we liked. The apps.py file was a file that just defined basic configuration settings. Models.py was one we were using to define our different models, whether they were airports or flights or passengers. And we dealt with URLs and views last time, too, in order to manipulate what people see and what URLs they have to go in order to see it. But the one file we really didn't touch last time was this tests.py file. So Django comes built in with its own testing framework in order to make it easy for us to run tests on our web applications, because it's designed with this idea that we should make sure that our application is passing our tests before we deploy it for users to use. And so if we open up test.py, here's some tests that I've written in order to allow and facilitate for the process of testing this web application. And so the first thing you'll see up at the top is that I'm importing from Django.test, I'm importing test case. Test case is an extension to the unit test framework. Django has taken unit test and built onto it in order to make it easier to test some Django web application specific things. And you'll see examples of that later. And so here's my class that's going to contain functions for each of the tests that I want to run. And inside of this class, the first thing that I do is set up the tests. So this is a function setup built into the test case framework that is going to run before any test ever runs. So before any of my individual test functions that we're about to see ever actually happen, the first thing that's going to happen is that this setup method is going to run, which is going to do a couple of interesting things. And it's just going to set up the tests such that I can test things that I care about later. So maybe I care about testing things about airports and flights. So in order to really test this, the first thing that I want to do is set up those tests by creating some airports and creating some flights inside of my database, such that I can then run some tests to make sure that they're behaving the way that they should behave. And so on lines 11 and 12 here, you see that I'm creating new airports. So this is a slightly different syntax for creating objects than we saw last time, where before we just used airport and then all of the properties, and then we saved it. This is another way of achieving the same thing. Just wanted to show you both. And so we can say airport.objects.create, create a new airport with code AAA and city, city A, create another one with code BBB and city, city B, and then create a whole bunch of these individual flights, where this has origin A1, A2, duration 100, and a couple others have different origins and destinations and different durations. Now, what am I actually going to test? Well, let's take a look at an example of a function that I might be interested in testing. So I've added to models.py, I've added to the flight model this additional function called isValidFlight. So the issue came up during last week's lecture of, well, right now, based on the way that the flights are set up, it's not at all clear that a flight is necessarily a valid flight. It might be the case that someone could create a flight that goes from London Heathrow Airport to the same airport. And that wouldn't really be a valid flight, but we'd be allowed to do it based on the way that our database is set up. And so maybe we want to add a function that is going to take a flight and check to make sure that it is in fact valid. And so That way, when we display the page that displays information about that flight, it would also include information about whether that flight is valid or not, and if it's not valid, then we could do something about it. We might also, likewise, you can imagine we could extend this to have a page that would just show me all of the currently invalid flights, all the flights that that don't satisfy some constraint that we want to have on flights. And so what does my isValidFlight function do right now? Well, right now it returns a Boolean value, true or false, of indicating whether or not a flight is valid. And what does it mean for a flight to be valid? Well, in this case, I'm saying a flight is valid if the origin of the flight is not equal to the destination. In other words, it starts somewhere and ends somewhere else. If it's starting and ending in the same place, that's not a valid flight. And likewise, the duration needs to be greater than or equal to 0. I don't want a negative length flight because that wouldn't make a whole lot of sense. Questions about isValidFlight? OK, so now what I might want to do is actually test this. Make sure the isValidFlight method is actually going to work. Because if I'm going to use it inside of my view, for instance, then it better work. And in fact, I do use it in my view. Because if I take a look at the flight.html page, this was the page that before showed me just information about the flight number, origin, and destination. I've added an additional list item here that's just indicating whether or not the flight is valid. So valid is just going to be true or false by accessing the isValidFlight property of the flight, which will now tell me whether the flight is valid. And so you'll notice that if I run the the Django server now, and go here, and I click on an individual flight, then what I get is this additional property on the flight page that says valid true, meaning this flight is valid.